Rutherford alpha particle scattering experiment. This experiment led to an atom model called nuclear atom model. Prior to this one, there was a model proposed by J.J. Thompson, which is something like this. An atom consists of a sphere on which a positive charge is uniformly distributed and negative electrons are embedded into it, like seeds in a watermelon or cherries in a cake. It is something like this. Let us say there is a sphere, this is an atom according to Thompson model, on which positive charge is uniformly distributed, and then you have negative electrons which are embedded into it, something like this. This is the model given by Thompson, and the experimental observation in those days, like thermionic emission, can be explained on the basis of this one. When certain materials are heated to a high temperatures, electrons are emitted. Negatively charged electrons are emitted, but positive charged particles are never emitted from atoms in thermionic emission. So that can be explained based on this model, like since electrons are small particles which are embedded into atom, a sphere, and when you heat that atom, these electrons acquire energy and come out of that sphere. That is the explanation which was successfully given. But there are other several phenomena which could not be explained on the basis of Thompson model, such as when cathode rays are made to incident on materials, they penetrate and pass through that particular material. This cannot be explained on this model, Thompson model, because if an atom were to be a solid sphere, then an electron, cathode rays consists of stream of electrons. These electron may be heating this sphere and gets embedded into it. It can never come out of that sphere if it is a solid sphere. But we know that the particles, electrons in cathode rays can penetrate through that materials having small thicknesses and come out of that one. So to overcome such problems, Rutherford proposed a different atom model which came to be known as nuclear atom model. Actually, the experiment which finally gave that atom model is this one, Rutherford alpha particle scattering experiment, that we will see now. This is an experimental arrangement for the alpha particle scattering experiment. You are having a source of alpha particle, a radioactive substance is placed inside and it will emit alpha particles. Generally, radioactive substances with mass number greater than 200 will emit alpha particles. Such a source is taken and from that alpha particles are emitted. The stream of alpha particles are made into a narrow beam using lead slits. 2 lead slits are used with which we can obtain a narrow beam of alpha particles. Then we are having a thin gold foil, a very thin gold foil placed in this position, and the alpha particles are made to incident on the gold foil. After that, we are having a detector which is basically a microscope, and it is fitted with a zinc sulfide screen, and there is an arrangement with which you can move that screen on a circular path so that you can position that screen at any point, and you can also detect the alpha particles. As soon as the alpha particle stream strikes the screen, the zinc sulfide screen, it will produce a flash, a glow with which you can detect the alpha particle. That is the arrangement, and by moving this particular detector at various positions, they have observed the number of alpha particles that are coming to various angles. From this experiment, it is observed that most of the alpha particles are penetrating through that gold foil without any deviation. They are traveling in the initial direction itself without any deviation from the original path. Some of them are suffering a deflection by a smaller angle, and very few of them are having a angle of deflection greater than 90 degrees. Like it is observed that 1 in 8,000 alpha particles are suffering angle of deflection greater than 90 degrees, that is a large angle of deflection is suffered by very few alpha particles, that is 1 in 8,000. Now, why this is happening? Suppose if you take that earlier picture of Thompson atom model, this is not possible, because since the positive charge is uniformly distributed on the atom, alpha particle which is incoming towards the atom. See, alpha particle is also a positively charged particle, therefore, between the atom and the alpha particle there must be a repulsive force. Due to that, this alpha particle may get deflected, but if the positive charge is uniformly distributed on the sphere of atom, like the earlier picture of Thompson atom model, if that is true, in such case what will happen is, these alpha particles, all of them should be uniformly deflected by the same angle, but it is observed that some of them are getting passing through that undeviated, very few of them are suffering some of the angle of deflection, and very few are deflecting by a very large angle. It is something like this. For example, if this is a thin gold foil, some of the alpha particles which are positively charged are moving undeviated like this, penetrating through that thin foil of gold, and some of these alpha particles might be suffering a small angle of deviation, something like this, that is angle of deviation, and very few of them are suffering a greater angular deflection. In fact, some of them are recoiled like this, making an angle of deflection of 180 degrees. That can be explained, that cannot be explained on the basis of previous model. After this experiment, Rutherford proposed a different atom model. According to him, the entire positive charge of the atom should be concentrated in a small region, and most of the mass of the atom should also be concentrated in that region only. Only then this kind of large deflection for a very few particles can be explained. Like for example, if you are having a positive charge which is located at a small region, then only an alpha particle which is moving very close to this positive charge can get a deflection like this. Suppose if it is moving far from this positive particle within the atom, then what will happen is, there is always a possibility for this alpha particle to be moving without any deflection, because the repulsive force between this incoming alpha particle and the positive charge of the atom may be very less, therefore, it is moving without any deflection. Very few of them which is observed in the experiment may be having a head-on collision with the nucleus, like they are directly projected towards the positive charge of the atom. In such case, they will approach like this and then get deflected in the backward direction. They are almost recoiling, making an angle of deflection of about 180 degrees. This can be explained, the experimental observation can be explained on the basis of this model, atom model, wherein if the entire positive charge is located in a very small region of the entire atom, and the remaining space of the atom should be empty. In such case, through that empty space the alpha particle can clearly penetrate. So, from that a nuclear atom model came into being. The Rutherford model is also known as nuclear atom model. According to this model, most of the mass and charge, positive charge of the atom is concentrated in a small region of the dimension of 10 power minus 14 meter. This is actually the dimension of the nucleus. That positive charge of the atom is named as nucleus later. That is why Rutherford is credited with the invention of nucleus. And the electrons which are negatively charged are outside the nucleus, and they are revolving in a circular orbit around the nucleus. And the dimension of the atom and the dimension of nucleus, if we compare, the dimension of nucleus is very less when compared to the dimension of the entire atom. In fact, the nucleus dimension is taken as 10 power minus 14 meters, whereas atomic dimension is about 10 power minus 10 meters. So, the picture given by Rutherford atom model is something like this. Now, the Rutherford atom model or nuclear atom model suggests that the entire positive charge of the atom and most of the mass of the atom is concentrated in a small region called nucleus. Next, electrons, which are negatively charged particles, are revolving around the nucleus. They are outside the nucleus and they are moving in a circular orbit, just like planets around the sun in a planetary system. So, there is a electrostatic attractive force between the positive nucleus and a negative electron, but that can be compensated by the centrifugal force that is experienced by the electron. Therefore, the electron continuously moves in a circular orbit. With this kind of picture, there are certain phenomena which are observed at that time can be explained successfully. Further, the dimension of the atom is about 10 power minus 10 meters, whereas the dimension of nucleus is about 10 power minus 14 meters. You can see that between that one there is a large empty space between the nucleus and the electrons. The dimension of atom is so large and the volume of the atom itself is very large when compared to the volume of the nucleus. It implies that there must be a very large empty space between the nucleus and the electrons. Using this concept, we can explain why cathode rays are penetrating through materials of small thickness. When cathode rays are projected towards a material, they can penetrate through them between the gaps, that is, there is a large empty space between the nucleus and the electron. Any particle can easily penetrate through this one. In that way, we can explain certain observed phenomena. Similarly, when you supply some amount of heat, generally the electron, which is a lighter particle having a very less mass, will absorb energy and come out of that material. That is what thermionic emission is all about. Whereas a nucleus is a massive body, its mass is very large. According to the nuclear atom model, the mass, most of the mass is concentrated in this nucleus itself. Since nucleus is very massive particle, whatever might be the energy supplied to the atom, a very small fraction is absorbed by that one and it is literally not affected. Therefore, this positive charge can never be emitted during thermionic emission. In this way, the observed phenomenon can be explained on the basis of Rutherford model. But you see, there are certain problems with this kind of model also. The electromagnetic theory says that when a charged particle is accelerated, it should emit energy in the form of electromagnetic wave. If that is the case, then the revolving electron, which is to be considered as an accelerated charged particle, also should emit energy in the form of electromagnetic wave. In such case, the energy of electron should gradually decrease and it should spiral in, finally falling into the nucleus. Once an electron falls into the nucleus, there should not be any stable atom. But this is not the case. In nature, we have observed several stable atoms. So, how can we justify Rutherford atom model with regard to this Maxwell's theory of electromagnetism? To overcome that problem, we have other model called Bohr's atom model that we will see in the next topic. Bohr's atom model. This model is proposed by Niels Bohr. In the earlier case, that is Rutherford atom model, there are certain shortcomings. To overcome that model, Niels Bohr has proposed a different model. This is called Bohr's atom model. See, the problem with the earlier case is that suppose if you have a nucleus which is a positively charged body, which is at the core of the atom, and you are having an electron which is revolving in a circular orbit around the nucleus. This is using this model we can explain certain phenomenon. But electromagnetic theory says that when a charged particle is accelerated, then it should emit electromagnetic waves. Since here electron is a charged particle revolving in a circular orbit, should be an accelerated charged particle. In such case, it should emit electromagnetic wave. the energy of the electron should be emitted in the form of electromagnetic wave. In such case, the energy of the electron should gradually decrease. If that happens, then the electron energy gradually decrease and it should move in a less circular path, a less radius circular. The radius of the circular path gradually has to decrease, and finally it performs a spiral path to fall into the nucleus. In such case, electron and atom does not exist, but we know that atoms, stable atoms do exist in nature. How do we explain this phenomenon? So, this to overcome this problem, Niels Bohr has proposed a different model, like most of this thing is kept as it is, but he proposed certain postulates to overcome this particular problem. There are certain postulates according to this atom model. The first one is an atom consists of a positively charged core, which is called a nucleus, and around this nucleus a number of electrons are revolving in circular orbits, and he defines what you call stationary orbits also. Like when an electron is revolving in this stationary orbit, then it will not emit any electromagnetic wave. That is, the radiation, the energy of the electron is not lost by the emission of any electromagnetic wave. That is a postulate. Like for example, if you have a nucleus and positively charged nucleus, you are having an electron which is revolving in a circular path. Now this orbit is defined as a stationary orbit, and as long as the electron is in a stationary orbit, it will not emit any electromagnetic wave. Once it is not emitting, then energy is not lost. Therefore, the energy of electron remains the same. It will continue to revolve in the same orbit. That is how stability of atom can be achieved. That is the model postulates. Then how can we define that stationary orbit? That is also given by the atom model, which says that for any orbit, if an electron is revolving in a stationary orbit, to define that stationary orbit, the angular momentum of the electron in that orbit should be integral multiple of h by 2 pi. Like h is Planck's constant. If you take h by 2 pi, then integral multiple of this, that should be equated to the angular momentum. If L is the angular momentum of the electron in the given orbit, then it should be integral multiple of h by 2 pi. In this, n is an integer, any value 1, 2, 3 and so on it can take. So, as long as this condition is satisfied, we can say that the orbit is a stationary orbit, and as long as the electron is in the stationary orbit, it will not emit any radiation in the form of electromagnetic wave. In such case, the energy of electron remains the same. It will continue to revolve in the same circular path. So, that is the explanation given by the Bohr's atom model using these postulates. Next, we also observe that when atomic gas is heated or supplied some kind of energy, it will emit radiation. Spectrum is emitted by several atomic gases. Why this is happening is also explained by Bohr's atom model. For example, you consider a particular atom in which there are a number of orbits or energy levels. See, an orbit can also be called as energy level because each orbit is associated with some kind of energy, and that is why it is energy level. Let us say E1 represents a lower energy level and E2 represents a higher energy level. If at all an electron is situated in a higher energy level, then there is always a possibility for this electron to fall into the lower energy level. See, generally lower energy levels are more stable when compared to higher energy level. If at all there is a vacancy in the lower energy level, then electron will always tend to fall into the lower energy level. Now, that is what happening when a gas is excited, the electrons will be sent into higher energy level. Since the higher levels are not stable, the electron again fall back to the lower energy level. In the process, energy is emitted. the energy is emitted in the form of photon. The energy of the photon is taken as h nu, and this h nu must be equal to the difference in the energy levels, that is E2 minus E1. When the electron is falling from this E2 level to E1 level, the difference in the energies is converted into a photon having energy h nu. Therefore, h nu must be equal to E2 minus E1. That is the observed spectra of various atomic gases is because of this phenomenon. When an electron undergoes transition from higher to lower energy level, the difference in the energy level is emitted in the form of photon, and that gives you the spectrum for us. So, that is Bohr's atom model. Using this one, several observed phenomenon can be explained successfully, and the hydrogen spectrum which is obtained can be exactly identified with the theoretical approach given by Bohr's atom model. It is very successful in explaining hydrogen spectrum.